We'll conclude Module 4 with a discussion of tabular representations. These are questions the CLEP exam loves to ask because they really test your theoretical understanding of functions. In these types of examples, they will typically not give you an explicit formula for the output given the input. Instead, they'll give you a table of values and ask you to fill in missing pieces. So this tests your understanding of composition of functions in particular. So let's take a look at an example. So here we give you a list of inputs, a list of values for f of x, and a list of values for g of x. And then we'll ask you to compute f of g of x at different points. So let's look at the missing values here. We have the entire column f of g missing. So let's start with f of g of 1. Well, what is g of 1? It's -4. So then the question is, what is f of g of -4? Well, I don't have that value here, so I cannot compute it because I don't know f of -4. It's a missing value here. How about f of g of 2? Well, g of 2 is -5. And again, I don't have that value here. So it's looking fairly hopeless. I don't really seem to have very much information. But on the next one, I'm asked about f of g of 3, which is f of 2, because g of 3 is 2. And then I see, okay, what is f of 2? It's 3. So I plug in 3 on this table here. Next, we'll look at f of g of 4, which equals f of 1, because g of 4 is 1. And then I go to the table and I read f of 1, which is 2. Next, we'll look at f of g of 5, which is f of 0, which is not on the table. So nothing there. And now let's look at f of g of 6, which is f of -1, which is not on the table. So in this case, there were only 2 values that I could use this tabular representation for. And this shows its strengths and weaknesses. In the cases where you can use it, it's a very nice description because it shows exactly how f and g interact. But to show many values, you need a very long table. So it's not really a very convenient representation for most types of mathematical applications. An explicit formula is usually more desirable in those cases. But it does test your theoretical knowledge of functions and compositions. So let's look at another one. Here we have a table that has more things to be filled in. So where possible, we'll try to evaluate f plus g of x, f times g of x, and also f of g of x. As before, it may not be the case that we can evaluate f composed with g everywhere, but we'll do it where we can. So let's start with the first row. So f plus g of x at -2. So I add f and g, and I get 0. The product is -1. How about f composed with g? Well, what is g of -2? It's -1. And what's f of -1? It's +1. So 1 goes here. We'll go down, and then let's see here. So 1 plus 0 is 1. 1 times 0 is 0. And then g of -1 is 0. And f of 0 is 0. So 0. Next, 2, 0. And then let's say that f of g of 0 is equal to f of 2 which is equal to 2. Ah, no, it's equal to 5. So we put 5. Next, we have 3 plus 1, which is 4. 3 times 1 is 3. And f composed with g of 1 is equal to f of 2, which is 5. Ah, no, g of 1 is 1. Right. And that means f of 1 is 3. Sorry about that. Next row, we have 5 and 2, so they add to 7, multiplied to 10. F composed with g of 2 is equal to f of 2, so 5. Next row, 4 times 4 is, or plus 4 is 8, times 4 is 16. F of g of 3 is equal to f of 4, so 2. And last row, 2 plus 3 is 5, 2 times 3 is 6, and f of g of 4 is f of 3, which is 4. Look at this. So this table is very typical of what you might see on the CLEP exam, where you have to understand how to add and multiply functions, which is not too difficult, but also compose them. To get some practice with this, take a look at the readings I've recommended and also work on some of the exercises corresponding to this material.